grade's only like a 10, so no, I'm kidding, it's 100. All right, we're ready for week 7. We got a lot of stuff to cover, so I'm gonna go kind of fast, but we're recording, so you can go back and watch the video if I go too fast. But I wanna make sure you understand last week's, because you didn't have a live lecture last week to understand, which is all about Poisson. So, quiz is on Thursday. I don't know what to say about that. We got too much to cover. Let's talk about week 6 homework that you just handed in. Let's go right here. Okay. Let me start by saying, where is it? Right here. Poisson, how do you recognize it? That's the key that I want you to get out of this beginning of this lecture, is how do you recognize the problem there? And to recognize it, it's always asking you the probability of how many during an interval. Let me repeat that. The question's always asking you, what's the probability of how many during an interval of some kind? Now, some people get it mixed up with normal probability, but normal probability is asking you the probability of how many, but it includes a standard deviation. So that's how you know it's normal probability, because you'll go, oh, there's a standard deviation in this problem, we must use normal. Boom, you recognize it. You're looking at this other problem. Hey, what's the probability of, let me go with something here. What's the probability of 10 knot holes in 14 linear feet of pine board? I was asking you how many, what's the probability of 10 knot holes? What's the probability of 10 knot holes is how many, the intervals, 14 linear feet of board. Now, I didn't mention anything about standard deviation in the problem. That's how you go, oh, this must be Poisson. That's how you recognize it. No standard deviation. It almost reads like a normal distribution problem, but there's no standard deviation. And it's asking you how many for an interval. The reason I'm emphasizing this is we're about to learn after this quiz exponential probability, which everybody gets confused with Poisson. So this is why I split it up this time. On this quiz, you know exponential won't be on there, and this is the one everybody mixes it up with, because it's going to be on your next quiz. And Poisson won't be on your next quiz. It's on this quiz. So there's no way this time anybody's going to mix it up. This is the first semester I separated them. But on the final exam will be both. Exponential and Poisson will be on the final, without a doubt. Because exponential, Poisson, normal, uniform, binomial are the main subjects of the whole semester. So you know they're going to be on a cumulative final exam. So right now, when you're reading a problem on the quiz on Thursday, it's a matter of you deciding, am I reading a normal probability problem or am I reading a Poisson probability problem? That's the only way you're going to mix them up. And one of them will have a standard deviation and one won't. That clears it up right there. All right, so there you go. That's how you recognize it. Now let's go to the homework. A highway study finds on average there's 5 potholes for every 6 miles of a particular highway. There it is, the mean. It's how many potholes per interval, 6 miles of a highway is an interval. Using the Poisson equation from Tetrafly's PowerPoint, show you detailed calculation probability for 4 potholes in 6 miles. Your first question on Poisson you should always ask yourself is the interval of the mean and the interval of the question the same? Because if they're not the same, you must adjust the mean. I want to repeat that. You never adjust what the question's asking. This question says, what's the probability of 4 potholes in 6 miles section of highway? Your X is a 4. You don't change that. But if it said 3 miles of highway or it said 12 miles of highway, you're going to recognize that's different than the mean description, and you must adjust the mean to the interval of the question. So if the mean's being told in 6 miles, but the question were in 12 miles, well, the interval doubled, so you got to double the mean. Get it? Or if the question's about 6 miles of highway, or I'm sorry, the mean is 6 miles of highway, and the question's 3 miles of highway, well, 3 miles is half of 6, so you got to cut the mean in half. You adjust the mean only, never adjust what you're being asked about. That's another mistake. Again, don't adjust what you're being asked about, the question. Always adjust the mean if an adjustment is needed. In this case, the mean is 6 miles, the question's about 6 miles, so we have the mean at 5, and our X is a 4. So a 5 and a 4. The formula says you take E, 2.718, to the power of the mean, which is -5, the mean negative. Now you take that mean, 5, and put it to the power of what you're being asked about, which is 4. All of that over what you're being asked about, factorial. 4 times 3 times 2 times 1 in this case, which would be 24. So I took E. By the way, it's real easy to use E if you use the calculator that's on the computer, because it has an E key right there. So E, 2.718, to the power of, so I go exponent of, and then I put 5, but I make it negative by hitting the plus minus key. And there is E to the power -5, and I put it right here in the answer, 0.0067379. Then 5 to the power of 4, 625. And 4 factorial, 24. And then you carry on your equation and you get 0.175466, or 5. If you're going 4 digits, 0.1755. I know some of you are only going 4 digits on the rounding inside these calculations, which is fine. The rule is go at least 4 digits. As you can see, I went more than 4 digits, which makes my answer a little bit different than your answer probably, but it's only because of rounding. So I'll see that. You're not going to lose any points. If you didn't go at least 4 digits, you only went 3 or 2, you're going to lose points. Does that answer? Okay. All right, second one. Second one says use the same information above, but this time find the probability of 2 potholes in 3 miles. The key to this was you recognizing the interval of the question is now half the interval of the mean. So you have to adjust the mean, never the question. No matter what, we're using 2 potholes. So our x is a 2 no matter what, but the mean is no longer 5. We have to split it in half, so the mean is now 2.5. So we're using 2, 2.5. So here it is, E to the power of -2.5, because the mean is now 2.5. We split it in half. 2.5 to the power of 2, 2 factorial. So this calculates out to about 25, 26%, right? Between 25 and 26%. Okay, that makes sense. Let's go to the next one. This is one more. Customers arrive at a local credit union at a rate of 4 per half hour during the afternoon hours. Here it is. 4 is how many per interval, which is half hour. Colin, pick up your homework on the way out, okay? 4 per half hour. Then it says, using the Poisson question from chapter 5, show your detailed work calculating what's the probability of 5 customers during the afternoon hours for a 30-minute interval. That was just a trick question. 30-minute interval and a half-hour interval are the same thing. So there's no reason to make an adjustment of that mean. The 2 intervals are the same. One's in minutes, one's in a half hour, but they're the same, so there's no adjustment. You're using a 4 for the mean, you're using a 5 for x, and you just plug it in. E to the power of -4 for the mean 4 to the power of x, which is a 5, and then x factorial, which is 5 factorial. So this comes out to about 15.5%, a little more than 15.5%. These were easy, right? Not bad. The only tricky one was you had to know to adjust the mean on that second one because of the interval being different. Now, let's go to these counting ones. This 4A and B was about you recognizing when do you use the combination formula, when do you use the permutation formula, and here's how I always remember it. Permutation formula is used if order matters. If somewhere it describes in the problem that the order that selection's being done has some significance, that it matters in some way. So I would just plain old put the word if order matters. I mean, I was being blunt as to what the second one's all about. The first one says order doesn't matter. So that's a combination. So it's, what are you being asked about? 6 tellers, you got 6 tellers showing up, but you only have 4 stations. So you're gonna have to, how many different ways can you schedule, or can you place the 6 tellers into 4 stations? There'll always be 2 tellers left out, but there's all kinds of different ways you can do it. So because order doesn't matter, meaning if we were to take the 6 tellers and label them A, B, C, D, E, F, whatever 6 letters are, whatever one we select first to put into a teller station in second doesn't matter. And that the order doesn't matter. So if I put A, B, C, D for the first one, but then I went D, C, B, A, they're the same because order means nothing. So that's why you don't have a lot of combinations, because D, C, B, A is the exact same as A, B, C, D. They're the same 4 tellers. But B, order matters. So if I put A in first teller, B in the second one, C in the third one, D in the fourth one, Now I do it again, and I put D in the first one, C in the second one, B in the third one, A. They're complete, they count as two different possibilities because the order mattered. So D, C, B, A is a whole different possibility than A, B, C, D because order mattered. So in that case, you're gonna have a lot more possibilities, 360 compared to only 15. So that's how you know the difference. You guys could all do these formulas, they were pretty easy. You're just using two numbers. How many stations were there? 4. How many showed up to work? 6. You know, the bigger number is always the one on top. These are easy. I gotta tell you, I'm not even sure this will be on your quiz because they're just too darn easy. The only trick to it is knowing whether you're gonna use one or the other based on did order matter. All right, so there's the written assignment. Let's go to the Excel. The Excel is tricky. This is tricky because of the more than rule. Poisson uses discrete data, 1, 2, 3, 4, 5, 6, not any of the numbers between there. So every question for Poisson is going to be about, it will never be, hey, what's the probability of 4.2 out of the 6 miles of highway? No, you can't have a 0.2 pothole. It will be a discrete question. What's the probability of 6 potholes in the next 6 miles or something like that? So with that said, you had to remember the binomial rule on a more than question. You had to use the 1 minus in front, but that first number has to be the opposite of the more than question. That was the trick to Poisson, that first number. Just like binomial. That was the same little trick. So let's read the first of all, the given information. A textile manufacturer, let me make it bigger so everybody sees this better. A textile manufacturer process finds on average 4 flaws occur every 60 yards of material. How many per interval? 4 flaws are how many? The interval is 60 yards of material. A, calculate the probability of exactly 3 flaws per 60 yards of material. Okay, the question is asking about 3 flaws. We would never change that, so we know X is 3. But do we change the mean? I look at the interval, the question's about 60 yards of material. The mean's being described as 60 yards of material. We don't convert the mean. X is 3, mean is 4, and it goes like this. The first number is your X, which is gonna be the 3. Your second number is the 4, which is your mean. And the last number is either a 0 or 1. Did I ask for 3 flaws exactly? Did I ask for 3 flaws or more, or 3 flaws or less? If it's a more or less, you've got to put a 1 on the end. If I'm asking for just one number, like exactly 3 flaws, you put a 0 on the end. Just like binomial, same rule. So that's why there's a 0 on the end, and the probability is 19.5% approximately. All right, before I show the next one, let's look at it again. Here we go. Calculate the probability of 3 or less flaws in a 60-yard piece of material. We know we're using a 3. We don't change that. Unless it's a more than, but we know we're using a 3, and it's an or less, so we know there's a 1 on the end. Now we gotta look at the interval. 60 yards, what about the mean? Oh, it's 60 yards, so we don't have to convert the mean, because the interval's are the same. So now we know we're using a 4 for the mean. So the first number, since it's not a more than, it's a less than, the first number is a 3. The mean, since we're not converting it, it's gonna be a 4. There it is, Poisson. 3, 4, 1, because it says 3 or less. What if this said 3 or more? What would I have to change? Anybody feel like confident enough to tell me what I'd have to change if this said 3 or more? Anybody? Seriously, this is being recorded, please. A 2 would be the first number. She's converting the first number instead of a 3 to a 2, because if it's more than, you've got to put the opposite in the parentheses and the other change. Sure. 1 minus in front. That's the other change. If it's a more than, just like binomial, same rule. Next one. What's the probability of 5 or more flaws, 60 yards of material? The interval is the same, no reason to convert the mean, but this time it's asking for 5 or more. So the number has to be the opposite. We're going to use the 1 minus, but that first number's got to be the opposite of 5 or more, which would be 4 or less. So a 4 would be that first number. Let's look at it. 1 minus Poisson, parenthesis. Look at that cough. It's still there. That was every couple minutes last week, that cough. It was bad. Where was I? Right here, 60 yards. So we don't have to change it. It's asking about 5 or more. The opposite would be 4 or less, so we put a 4 in front. The mean we don't convert, so it's a 4 and a 1, but the 1 minus in front. Okay, here we go with converting. What's the probability of 2 or less flaws for 30 yards of material? 30 yards of material should have grabbed your attention. It's half of the interval of the mean, so you got to take the mean and split it in half. So instead of it being 4 flaws, the mean would be 2 in this case, because the interval's less. What's x? It's asking about 2 or less. So we got a 2 and a 2. Here we go. Poisson, parenthesis, 2, 1. 2 or less, the mean got switched to 2, cut in half because the interval is half. The last one, the interval this time is 15 yards. The mean is described as 60 yards. So if now the question's 15 yards is a fourth of 60 yards, so we have to cut the mean to a fourth. Since the mean is 4 flaws, we would use 1 in this case. The question says 2 or less, so our first numbers are 2, our mean is a 1. Let's take a look. There it is, Poisson, parenthesis, 2, 1, and because it says or less, a 1. Help me out. 2 or more. 2 or more. We put a 1 minus in front, but what would be the first number? 1. Very good. The opposite of 2 or more. Very good. How do we feel? We feel like we could do a Poisson question. Do you think there's a Poisson question on the quiz on Thursday?
Yes.
Oh, wow.
Yes.
That's the loudest you guys have been all semester. Wow. What? But do you think you have to do it manually or Excel?
Both.
Well, Kelly, you're all over it.
Yeah?
You can leave. I don't even know why
I'm
you're
all
here.
over it?
You're all over it.
That's what I like to hear.
Okay. All right. Most important subject between last quiz and today, right? All right. I think you guys got it. Let's get to some new stuff. Let me see if there's anything I wanted to say here. Oh, wait. What was this? Hang on. Do we even need this example? No, we got so much to cover. I think you guys got Poisson. You don't need another example. What?
Is the last number always 1?
No, only if it's a more or less than would it be a 1 in Poisson. You would use a 0. I want to make sure you see this, Don. Again, look at this first one. Darn it, come on. Look at this first one. Because the question said, what's the probability of exactly 3 flaws? We had to use a 0 on the end. Because it said exactly 3. It didn't say 3 or less or 3 or more. That's just like binomial. Don't forget, normal distribution, you never use a 0. But with Poisson and binomials, zeros do come into play at the end. Good question. All right, now I want to go on to something new. Let me look at my notes, make sure I do this right. Slide, say we're going to this one right here. Here we go. All right, so let's see. We got all this done right here. We got this. We're going to do contingency probabilities, conditional probabilities, the addition law, the multiplication law. This is just about you. The addition law and multiplication law are all about if you have 3 pieces of the puzzle, can you use algebra to solve the 4th? Or if you have 2 pieces of the puzzle, can you use algebra to solve the 3rd? Something like that. That's all those are about. You're going to learn about the union and intersection of probabilities. So that's today. It's really simple. And if we have time, I want to get to Excel and do combinations and permutations instead of manually using Excel, if we have time. All right. So we didn't even write any of these in because they were so easy. Look at this right here. Right here. Markley Oil Collins Mining. This is, I usually go into this long story how this was really how we did this in the real world. I can't tell you how many meetings I've been in, and once you get to the upper management, you have meetings to decide when you're thinking about, hey, I've got an extra $1 million. This is what I'm thinking about doing it. Do we as a team want to take this kind of risk? Well, and this is a perfect example. I could be the finance. I was usually the finance person at the meeting, in charge of the accounting and business and finance and everything. And so, when at this meeting, I may say, and by the way, I've never been in a meeting to take this much risk. Just so you know, this is not reality because in most companies, you know, unless they're huge, are never going to take this kind of risk with an extra $1 million they have. For hey, we have this $1 million we don't need for the next 3 months. What are we going to do with it? We're going to try to make money off it, but we're not going to take this kind of risk in real life. I always took much less risk that would guarantee us to make money, but you know, it's just a matter of how much we can make. So in this case, this is pretend. I came to the meeting, you guys are there, and I said, look, we got this extra $1 million for the next 3 months. I did my cash flows, and in real business, by the way, every penny is figured out 5 years in advance. I've always had everything projected 5 years. Budget, expenses, revenue. So any accounting majors here, that's part of your gig. You're always projecting what cash will be needed for the next 5 years. You know how many employees we'll have, you know what payroll is gonna be, you can predict what raises are gonna be, everything. So for the next 3 months, I know we don't need this money, but we're gonna make money off it. So here's what I'm saying. I'm saying there's these 2 investments, one's Markley Oil, one's Collins Mining, and there's 4, we're told that based on how they do in the next 3 months, we could have 4 different possible outcomes on Markley Oil. We could make $10,000 for the next, in this 3-month period. We could make $5,000. We could break even, but we have the chance of losing $20,000 in 3 months. All right, so there's our 4 possibilities. A lot of risk. At the same time, we're also investing in this other company called Collins Mining, which says if you lend us this money, we'll give you 2 possibilities based on how our business goes for the next 3 months. We're either going to pay you $8,000 back, or you could lose $2,000. So there's the possibilities. One of those possibilities is going to happen for each company. So we need to figure out how many different possibilities we have, and I went ahead and put it on the board for you. Here's all the possibilities. Gain 10 with Markley Oil, gain 8 with Collins Mining, gain 10 with Markley Oil, lose 2 with Collins Mining. Every possibility is right here. There's the gain 8, lose 2, gain 8, lose 2, gain 8, lose 2, gain 8, lose 2. Then for Markley Oil, make 10,000, make 5,000, break even, lose 20,000. So how many do we have here? You take 4 possible outcomes times 2 possible outcomes. There's 8 total possible outcomes here, right? All right, now, I happen to apply some, matter of fact, let's look at all 8 of these right here. Oh, here we go. 4 possible outcomes for Markley Oil, 2 possible outcomes for Collins Mining, 2 times 4 is 8 possible outcomes. Here's all 8 of them, right? Gain of 10 and plus gain of 8. Overall gain. So together, what's the most we could make if everything goes right? Luck's on our side. Both companies are going to pay us the most they can pay us. What's the most we can make? How much?
18,000.
18,000. There it is. I'm going to circle it. Here's the best we can do. What's the worst we could do? What's the worst scenario that could happen? Everything goes bad for the next 3 months, and with both companies that we invested in. What's the worst scenario? $22,000 loss. We're betting possibly making 18,000, possibly losing 22. Right there, without any probabilities on here, in real world should say, maybe we shouldn't do this. Yeah? I mean, really? Come on. I mean, this should be bigger, at least. Okay, now here's the deal. Remember the different ways to apply probabilities? I said there's the classical method, like you roll a die, every side of the die has an equal chance. So if I take 1 divided by 6, there's a point blah 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 probability of a 1. Point, 1/6 the chance of 2, 1/6 the chance of 3. That's called the classical method, where you apply the same probability each one. If I said, hey everybody, apply the classical method to these 8, you would go 1/8, 1/8, 1/8, 1/8 probability of this every outcome. The second method we learned in this class was called the relative frequency method, where we take the historical possibilities of how many TVs we sold in the last 200 business days, and we use that history. Well, sometimes we sold 0, sometimes 1, sometimes 2, sometimes 3, sometimes 4. We never sold more than 4. And then we would take each one of the, how many times we sold 4 or how many times we sold 3, excuse me, and divide by the 200 days to get that percent chance. So there might be tomorrow now, we can calculate there might be about a 43% chance of selling 2 TVs. There might be a 15% chance of selling 3 TVs. That's called the relative frequency method, by looking at the historical past. But then there was that third possibility to assign probabilities, which was called the subjective method. And this is used a lot in companies. And that's, I'm going back to that meeting, we're all part of the executive team. And I'm presenting you with what I should do with this money and the possibilities I'm looking at here. But now we all talked about this at the last meeting. We meet every month, the executive team meets every month to make plan, what direction the company goes, big decisions are made, the main decision. And so we already knew this was coming, so we all did a little research on Markley Oil and Collins Mining. So now we're at the point to where, okay, we're about to invest this money next week. Let's debate what the probabilities are of each of these outcomes. Since we all did a little research, we can start saying, well, hey, I think that we have the highest probability of making $3,000. Everybody agree, looking at these subjective numbers here. And someone will say, hey, I think the highest probability of making $3,000 is here because Collins Mining is so risky. Someone's arguing, I think they're really going to end up losing the 2,000, but I think we're going to make money no matter what on Markley Oil, and maybe it's not 10,000, but I think we're going to make 5,000. Then someone else will go, okay, well, here's what I think. No, I think, where's the second one? No, I think we're going to strike gold. I think the next 3 months are going to be great for both companies. I think we're going to make the most we can make on the first investment and the second one too. I think we're going to make 18,000. And someone else says, well, you know, we're not going to be able to avoid this. There's definitely a chance of this happening. And all that debate, we then came up with these probabilities of each outcome based on everybody's opinion, and it was called the subjective method. As long as the outcome, the probabilities of each outcome add up to 100%, we did our job to the best of our ability. This is no different than someone who is saying, there's a big football game this Sunday, and I'm gonna project how many points one team's gonna beat the other team. We don't know exactly how that football game's gonna turn out. We're looking at all the statistics on these football teams, and those who are experts on predicting said, this is the spread. So everybody start betting, because here's the spread. That's the same way it is in business. All of us are experts at that table. We're debating what that probability of each of these decisions are, because it's $1 million decision, even though it's only 3 months. And so now that we have these probabilities, then we start asking questions like this. Now, look at these probabilities. Think about what I'm about to ask you. Know which number's Markley Oil, which number's Collins Mining. What's the probability that at the end of 3 months that at least Markley Oil would have made us money? Let me say that again. What's the probability at the end of 3 months that Markley Oil made money for us? Tell me what numbers you're using. Let me hear one. I can't hear it. 18%? Where's that at? No, the percentage. Give me a percent. We're trying to find the percent chance, the probability, that Markley Oil made money from us, that first investment. Give me the number. 0.10. 0.20, 20%, that's Markley Oil making money. I heard another one, I didn't hear it.
08.
What? Say it again. 0.08 I heard. 0.16. 0.26. 0.10. Markley Oil's not making money on 0.10. Markley Oil's breaking even. And Markley Oil's losing money. The only ones that statement makes sense, that what's the probability that we're going to make money on the first investment, Markley Oil, it's just those 4 added together. All right? Hang on. Right there. 20% plus 8% plus 16% plus 26%. This equals 70% chance. Okay, there's a 70% chance that at least the first investment will make us money. Excuse me. That's pretty good odds based on all our debate. I bet on that, but hang on a minute. What percent chance is there the second investment will make us money? I'm asking about the second investment only. What percent chance is there Collins Mining will make us money? Go ahead, hit me. 0.20, there you go, I heard it. 0.16, that's correct. 0.10, that's right. 0.02. Is there any others that have Markley Oil making us money? It's wherever the 8s are. 0.02, 0.10, 0.16, is that right? And 0.20. The probability of Collins Mining making us money, 2016, 10, and 2 is 48%. Wait a minute, 48%? There's less than a 50% chance of us making money on Collins Mining after we debated all this. It's almost like, why are we taking the risk on Collins Mining? There's a better percent chance we're going to lose money. But let's say we didn't recognize it. The meeting's still going. All right, we're still going here. We got a red flag. No one bets to win on 48% chance. They'd rather bet on the 52% chance, right? So, here's the next question. The next question is, there's what's called the union and the intersection. One means and, one means or. The union, I better check before I say this. I don't want to get this wrong. It's been a little while. Which one's the or? Here we go. Blah, 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 blah. Or. The union is the or. The intersection is A and D, and. Now let me say it this way. You ready? What's the probability that Markley Oil or Collins Mining makes money in the next 3 months on an investment? Let me repeat that. This is called the union, meaning only one of these statements have to be right. One or the other. That's called a union of two events. One event is that Markley Oil is going to make money, or the other event, Collins Mining makes money. So start hitting me with the percentages, using these percentages here. Let me repeat it. What's the probability that Markley Oil or Collins Mining makes money? One or the other. What's the first one? 0.20, 0.08, 0.16, 0.26, very good. 0.10, very good. Oh, way to skip 0.12. That was a key, crucial moment there, because that's not making money, that's break even. That's losing 2,000. That is not in the equation. Because neither one are making money. 0.02, because yes, we got a company, but not that last one. This one and this one are not, the other 6 are there. That's called the union of two events. Let's look at it. Where one or the other is 20 plus 8 plus 16 plus 26 plus 10 plus 2 is 82%. All right, you got it. Now let's do intersection. Intersection is all about you recognizing which ones fulfill the question if the word were and, A and D. Let me repeat it. What's the probability that Markley Oil, the first investment, and Collins Mining, the second investment, both make money? Let me repeat that. Markley Oil makes money and Collins Mining makes money. Both make money. Start at the top. Is 0.20 in this?
Yes.
0.20, 0.08,
No.
0.16?
Yes.
Look at that. 0.26,
No.
0.10,
No.
0.12,
No.
0.02,
No.
0.06?
No.
That's right. There's only 2 of them where they're both making money. The probability that we come out of this at the end of 3 months making money off both companies at the same time is not that good. 36%? Is that it? We're walking into this grand scheme here with only a 36% chance that both of these are going to turn out good. Odds are 64% chance that one of them we're going to lose money on or break even. So it doesn't look like that good of a decision. Let's look at the intersection. Here it is. Just the 20% plus the 60% equals 36%. Okay, now, before I get into, I gotta figure out, I wanna make sure I do this in the right order so I don't start losing people. Before I get into the additional law and the multiplication law, I wanna show a contingency table, because this is the same thing. The only difference, what we're about to look at, is that these numbers are in a grid instead of lined up like this. That's the only difference, so don't let it confuse you. That's why I wanted to make sure you saw this example. And look at this example, it happens to be your homework. Wow, can you believe it? When's this homework due? Week 7 homework.
Tuesday.
What, when? Wait, no, stop. You guys never look at the, what, you don't go to the syllabus page on Canvas, you don't open the syllabus, nothing, you don't read the instructions, nothing? Nothing, when's it due? Should I bring up the instructions, is that what I should do?
There's no due date.
There's a due date on there, I can see it right here. I underlined, it's big capital letters, I mean, come on, what do you mean there's no due date?
Do never.
Yeah, there's a good date. There you go. All right, there's the due date, never. So, I'm going over it. I'm gonna post answers tomorrow anyway, or tonight maybe,
Ah, shit.
right? but let's look at it. Look at this table. Slept on the job, you guys should be familiar with this. Slept on the job, no or yes. And then 2 professions were asked, IT professionals and government professionals. So we went ahead and surveyed. Let's look at the numbers, 151, 102, 189, 108. How many people did we survey? It's in the description, by the way, I've given it away. 550. We don't have to add those all up, there's 550 there. Look at this, 550. By the way, what's this?
How long it took you to get here?
108 minutes today to get here. When it's usually 65 to
Where you
68
live,
minutes.
man? Keep telling us this.
275 must be a whole new highway when we're done.
Right, let me see the.
108 minutes to get here. I can't believe I'm here on time. I might as well just got out of the car and walked along it. Just like steer it from outside the car.
Where you live at? What's the county zip code?
So here we go, 550 is our number. You ready? Question 1 says, what's the probability that a random selected worker has answered that they have fallen asleep on the job? Now, how many people said they fell asleep on the job? Look at those numbers. Here we go. How many said, yes, I fell asleep on the job? What numbers do I need to add up? 102, 108, there's my numerator. And my denominator is how many people answered the survey? 550. That's how you use these contingency tables. Let's read the next one. Oh, this is too easy. Is this going to be on the quiz? Oh, stop. What makes you think that? Why do you say? Because why? Listen, I'm just like the rest of those professors. I do not make the quiz just like the homework. This homework's a waste of your time. Right? So here we go. 2. What's the probability? Oh, I gotta show the grid. There we go. What's the probability that a randomly selected worker is an IT professional? IT professional, randomly selected worker. Go ahead, hit me with it. 151 plus 102 divided by 550. We're getting this? Okay, here we go now. So we're now going to learn conditional probability. We're right here. That was contingency table, but conditional probability. How do you recognize a conditional probability? It's saying that something happens first, like it's given. Something's given or happens first, then it asks you the probability out of the after this other things happen. All right, I'm going to throw one out there because I don't even know. Yeah, given. Here's a given. Number 3 then, I'll do. Hang on. I knew my throat was not going to be ready for speaking, but I didn't think I'd start coughing. 3. If given a randomly selected worker is an IT professional. Stop. That sentence right there is saying, don't look at the government professional. We're only looking out of the IT professionals. That given is trying to tell you you're not going to use all 550 in your denominator. You're using the given in your denominator. So let me start and read it again. If given a randomly selected worker is an IT professional, meaning they're already an IT professional. So my denominator is going to be, what's IT? 151 plus 151 plus 102. There's my denominator. And when you read the next sentence, what's the probability of whatever? It's only out of the IT professionals. You cannot look at any other numbers now because the first event has happened, the first thing. Given, we just selected an IT professional. So given we selected an IT professional, what's the probability that he or she has fallen asleep at work? What number's in the numerator? Can't hear you. 102. Because we can only look at the 151 and the 102 because of that given, which is that first column. And the row out of that first column that represents yes, fell asleep on the job is the second row, which is 102. That's how you do a conditional probability. Now let's do I need you to make sure you got conditional probabilities. So we're going to, whoops, I don't know if there's a class next door, that could be bad. So we could do this. You ready? Now, tell me when you're ready. Look at this. Don't forget, the first one's Markley Oil. The second one's Collins Mining. You've got a table on your quiz. The question says, Given that we're gonna make money off Markley oil, given we're gonna make money off Markley oil, what's the probability we also make money off Collins Mining? Let's start with the denominator. The denominator, given that we're gonna make money off Markley oil, given, so what's in the denominator? Give me the numbers. 0.20, yes? Given Markley oil is gonna make money. That's the first investment. 0.20.
0.08.
0.08, there you go.
0.16.
0.16 is two easy things. 0.16 and 0.26. There is the denominator, because that's the given in this conditional probability. Given Markley oil is going to make money, what's the probability Collins Mining is going to make money? Now look, you can't even look at these bottom four, because this is not in the condition. That first statement that given Markley oil has made money, we can only look at these top four. We can only take into consideration out of these four probabilities, which ones also represent that Collins Mining made money. The 0.20, yes. The 0.08, no. The 0.16, yes. The 0.26, no. So those two, 0.20 plus 0.16, there's your numerator. That's how you do conditional probability. How do we feel? You want to see one more conditional probability? You do? You do? Okay. All right. I want to make sure you get this. Work on your denominator first, then your numerator. Given that we lost money on Markley oil, what's the probability we'll make money on Collins Mining? Given we lost money on Markley oil, let's go to the denominator. What probabilities are in the denominator given we lost money on Markley oil? Give me the probabilities in the denominator. 0.02 plus 0.06. Given we lost money on Markley oil, those are the only ones we lost. The break even, it doesn't count as a loss. I almost said given we didn't make money on Markley oil, but I wanted to, you gotta hear the words and figure it out. Now that we know the denominator, given we lost money on Markley oil, only these numbers could possibly be in the numerator because this is the given. What's the probability we make money on Collins Mining? What number goes up there? The 0.02. Because that's the only one out of these two that the Collins Mining is making money. The condition, the given, is the denominator. The probability question is the numerator, but it can only come out of the given. I hope we got this. Is there one more on the homework? There might be one more on the homework.
That's only for conditional, right?
We're only for conditional probability, which you'll recognize because it's trying to give you a given. Look at number 4, it's really small, hang on, but I can't show the table at the same time unless I go small. Okay, here we go, we can see them both. What is the probability that a random selected worker, oh geez, that's not it, hang on, let me go to number 5. Okay, I'll show you the table in a minute. Here we go, number 5 says, if given a randomly selected worker is a government professional, so what's in the denominator? Given a randomly selected worker is a government professional, what numbers are in the denominator? 189, 108. There's your denominator. Now it says, given a randomly selected worker is a government professional, what's the probability that he or she has fallen asleep at work? What's the probability that he or she has fallen asleep at work? What number's in the numerator? The 108 out of those two numbers. You got it. That's how you do a conditional probability, using a contingency table. When it's in a grid with columns as that, it's called a contingency table. So we were just doing contingency probabilities just now. Wow, what time is it? That went fast. All right, let's get this Excel real quick. Here it is. These are just like your written homework from last week. Combination, permutation. Excuse me. Combination, permutation, but you're using Excel functions. Before I show you the Excel function equation, I want you to tell me if this is a combination or a permutation. Remember the rules. One of them, order matters. One of them, order doesn't matter. So I'm going to read this. You tell me if it's a combination or permutation. It says, You are the manager of a customer service phone-in department. You have 11 customer service representatives scheduled today, but there's only 8 telephone call receiving stations. 11 customer service reps, 8 stations. There's the 2 numbers. You decide to randomly select 8 reps and assign them to the 8 stations. A, how many different ways can you select 8 reps if order matters? Combination, permutation. Combination, permutation. If order matters is always permutation. If order matters, it says if order matters. So permutation, P-E-R-M-U-T. P-E-R-M-U-T. The first number is the bigger number, the second number is the smaller number. 11 customer service reps are scheduled. There's only 8 stations to assign them to. All right, the second one says, how many different ways can you select 8 tellers if order does not matter? That's how you recognize it's a combination. Here's the combination, C-O-M-B-I-N, combin. The first number is the bigger number, 8 reps are scheduled. The second number is how many stations, 8 stations to assign them. All right, let's go to this next one. This is your chance. This is your chance to recover. You ready? I want to hear you. Are you ready? Okay. Assume a high school swim team coach has 6 possible swimmers, but it's a 4-person relay team. So he's got to select 4 out of the 6. If order of the swim relay is unimportant, how many different possible team organizations do you have? Is this combination or permutation? Combination, because it says if it's right there, if order of the swim relay is unimportant. There's the key words to let you know it's a combination. So C-O-M-B-I-N, parentheses, 6 swimmers, comma, 4 on the relay team. 4 different ways, or 4 ways to put them. 15 different ways out of those 6 swimmers. The second one says, assume the swim relay team that order is important. How many different teams are possible? And this way it's going to be permutation, P-E-R-M-U-T, parentheses, 6, comma, 4. 6 swimmers, 4 on the relay team. These are so unimportant that I can't imagine these being on the quiz. But you never know. You never know. It's not completely finished yet, but it's kind of complete. It's almost finished. How's that? Okay.
Let me look.
That's all I got. I went pretty fast. I got stuff to hand back if you came in late.